Today's lesson is picking up where we left off. We were on page 1088. We just finished problem 2 dealing with the mean, median, and mode and when to use the mean, median, and mode in different situations. We're going to continue that practice here today with problem 3. So problem 3 says mean or median, which is greater and when. It says previously you learned about 3 common distributions of data: skewed left, skewed right, and symmetric. You've also learned about the distribution of data and that it can determine when the mean or median is greater or less than the other. So take a look at the diagram or diagrams shown below. So the one on the left is skewed right. It says the mean of a data set is greater than the median when the data is skewed to the right. In this case, the median is the best measure of the center because the median is not affected by very large data values. So when it's skewed to the right, most of the values are in the left-hand side of the graph, whereas there must be a really large value on the right-hand side of the graph. That will affect the data and affect your mean, but the median is not affected and gives you the best indication of what most of the values are like. In a symmetric graph, the mean and median are equal, and we had some examples like that today where we saw how the mean and the median were equal when we had symmetric graphs. In this case, the mean could be the best measure of center. I guess you could really go either way, but the mean would give you that average. When a graph is skewed left, the mean of a data set is less than the median, and the median then would be the best measure of center, because again you'd have some really high values to the right, but then a few low values to the left, which could throw off your data, affect your mean, which wouldn't give you a real accurate representation of the data. So one of the most important things to understand is this part right here. The median is not affected by very large or very small data values, those outliers. Okay, very large or very small, those are those outliers. I like how my spelling's nice and neat. It looks pretty. But those outliers can affect data values, especially the mean. So in those cases, we want to stay away from the mean when we're trying to represent data accurately. The next problem is problem 1. It says for each plot shown, first describe the distribution of the data, then determine whether the mean is less than, greater than, or equal to the median. Now, this right here is a stem and leaf plot. You had a stem and leaf plot in your homework from yesterday. The column with the 5, 6, and 7, that represents the tens place. So the tens place, the 5, 6, and 7. The ones place is to the right of that in the column. So if you're looking at the 5 tens place, we have 1, 2, 3, 4, 5, 6 values. The values would be 54 because 5 tens, 4 ones, 56 because 5 tens, 6 ones, 56 again, 5 tens, 6 ones, 58, 58, and 59. Okay, the values in the 60 or the 6 tens place would be 60, 60, 61, 62, 63, 63, 64, 65, 66, 66, 66, 68, 68, 69, and 69. Okay. Now, looking back at what the problem asked us to do, it says describe the distribution of the data, then determine whether the mean is less than, greater than or equal to the median, or about equal to. So if we're reading that carefully, that doesn't say anything about having to solve. Right? So describe the distribution, then determine whether the mean is less than, greater than, or about equal to the median. So finish that up. When you're finished, unpause the video. So looking at number 1 and the data values, you can see that the distribution of the data is pretty close to symmetric. On the midpoint, the stem and leaf plot where there's a 6, you can see it on the top and the bottom of that, the 5 and the 7, there's 1, 2, 3, 4, 5, 6, 6 values in the 50s and 5 values in the 70s, pretty much balancing out that data. As a result, the mean is about equal to the median in that case. So then take a look at letter B. This is representing the number of text messages sent by 6th graders. So again, tell me what the distribution of the data is, and then tell me whether or not the mean and median are equal. So looking at letter B, number of text messages sent by 6th graders, you can see that the graph is skewed right because there is a lot of values here and then a small amount of values on the right hand side. When I said here, I meant on the left hand side. Small amount of values on the right hand side, so it's skewed right. So those values on the right, those large values like 100, would throw off the mean a little bit. And as a result, the mean would be greater than the median. I want you to tell me why here. Okay, so tell me why the mean will be greater than the median. Make sure that you do that and then unpause the video. It would be greater, the mean would be greater than the median because of those high values, the hundreds and 90, that would throw off the mean and raise it up rather than the median keeping it all in the middle. Okay, so the mean would be a little larger because of those high values. Alright, do the same thing with C. Again, tell me the distribution and then tell me whether the median is greater than the mean or the mean is greater than the median or whether or not they're equal. When you're done, unpause the video. Alright, looking at the distribution, you can see that the data is skewed to the right because there's a small amount of values on the right side which could potentially throw off the data. It might be an outlier. Okay, that term outlier again is important. Even though I ran out of room for it as I was writing it, it is important because it can throw off the mean and in this case make it greater than the median. Right, what I'd like you to do next is finish problem 2. For each part, should the mean or median be used to describe the center of data? You can go ahead and do that now. For the first one, 1A, what you should use is the mean. You should use the mean because it's the balance point of the data, and since it's a symmetrical graph, the median and mean are going to be very close. The mean will give you that average, that balance point. So use the mean for the symmetrical graphs. For B, since it was skewed to the right, you would want to use the median because the mean would be affected by the outliers. The same goes for letter C. Must have a basketball game or something on my mind. I don't know, Brewers are playing. The same goes for letter C, because the data again was skewed to the right, so the median would be the best because it's not going to be affected by that outlier.